In my previous video, I gave a brief introduction to descriptive and inferential statistics. And in this one, I will focus more on statistical data analysis and give a brief introduction to this analysis. So, I will talk about statistical significance. I will talk about measuring the strength of associations among variables. I will also touch upon parametric and non-parametric tests, give some examples of parametric tests and non-parametric tests, types of analyses for one, two, or more variables, and then we will discuss a little bit about the assumptions and the examples of tests that go with those. All right, so statistical significance again is basically we are trying to look at whether the results are statistically significant, which means that the probability of obtaining such results or findings by chance is less than 5%. This is if we adopted the level of significance of 0.05. So findings would occur no more than 5 out of 100 times by chance alone. Okay, so that's what the statistical significance means. What if your study finds there is an effect? Okay, so you will need to measure how big the effect is. You can do this by using a measure of association. And you can take a look at an example of when such measure of association is used in a research article shared with you via Blackboard. So the next slide, for example, will give you more information on this. So let's take a look. So measuring the strength of associations among variables, and here's an example. In Sehlawi and Shingi 2013, this article was shared in your course for a description and discussion of how a measure of association, the value of Kramer's V, for example, in this case, was used in a chi-square statistical test. This test represents, for example, in the study, the magnitude of association between the ESOL, license, and success in the applied linguistics test that was administered to those teachers. All right, parametric versus non-parametric tests. Parametric tests assume that the variable in question is from a normal distribution. Non-parametric tests do not require the assumption of normality. Most non-parametric tests do not require an interval or ratio level of measurement. They can be used with nominal or ordinal level data. Normality. Normality, how do you know if the data that you are dealing with are normally distributed? Basically, you will just run a test or histogram in SPSS to determine if data meet the normality assumption required for parametric tests. SPSS will create a graph to demonstrate the normality or non-normality of your data. Types of parametric tests. When we talk about parametric tests, we are talking about tests such as Ttest, Anova, Pearson's correlation test, and linear regression test. And here's an advanced tip. When we deal with linear regression, which is the next step up after correlation. It is used when we want to predict the value of a variable based on the value of another variable or other variables. For example, you could use linear regression to understand whether language achievement exam performance can be predicted based on revision time. To run this test, you need to test for at least 6 assumptions. Among these is the data interval or ratio, and is it linear, and so on and so forth. So those relationships can be again assessed or tested through SPSS. Types of non-parametric tests would include Mann-Whitney test, Kruskal-Wallis test, chi-square test, and Wilcoxon test. The good news is that you are not required to manually calculate these tests. SPSS again will do the job for you. You just need to know how to code your data and enter the data into the system. It takes less than a minute for SPSS to generate your graphs and tables. For more guidance on how to use statistical package for social sciences in second language acquisition, please check the guide on doing statistics in second language acquisition under your course documents. Non-parametric tests, or you would use non-parametric tests when all assumptions of parametric tests cannot be met. So they can be used when data that are not normally distributed. That's when we use non-parametric tests. Types of analyses for one variable. So if you have a univariate analysis, in this case, the analysis of one variable, you will basically be looking at some descriptive statistical analysis such as the mean, median, mode, range, and standard deviation. Okay. Types of analysis again for two variables, bivariate analysis. This is a kind of data analysis that explores the association between two variables. Some examples of bivariate analysis include Pearson's correlation, Ttest, Spearman's row, Mann-Whitney test, linear regression again are examples of statistical analysis that can be used for two variables. Types of analysis for more than two variables, multivariate analysis, the analysis of more than two variables. Some examples would be multiple regression, multiple logistic regression, and chi-square in that case, okay? Examples of research questions with different variables. So if we take the example of one univariate analysis, an example from TESOL and applied linguistics would be, how many ELs speak Spanish as L1 in Huntsville? So that's a very basic one variable analysis. Example of a bivariate analysis would be, are L1 proficiency and L2 proficiency levels correlated? Example of a multivariate analysis would be, do age, motivation, learning style, and SES, socioeconomic status, predict second language acquisition reading proficiency? Now we move on to the concept of assumptions. Selecting the appropriate statistical test requires several steps. The level of variable, okay, the type of variable you are dealing with. Is it interval? Is it ordinal? And so on and so forth. And this is a major component in deciding what test to use. Statistical test selections should be based on, number one, what is your goal? What's your goal of your study? Is it a description? Is it descriptive? Are you planning to do a comparison? Is it prediction? Or are you trying to quantify an association? Or prove effectiveness? Or prove causality? So those are important things to keep in mind. And then next is, what kind of data have you collected? Is your data normally distributed? Can you use a parametric or non-parametric test? What are the assumptions of the statistical test that you would like to use? Does your data meet these assumptions? So that's how you can decide on your statistical tests. There are various assumptions when it comes to statistical analyses. So for each test, there are certain assumptions that have to be met. So before you select a test, be sure to check the assumptions of each test. You will need to review the statistical and research methods resources provided to you to find this information. Again, SPSS is a great resource for you to run tests for the various assumptions. Some examples of common assumptions are, one, the dependent variable we need to be measured on a certain level, for example, interval level. The independent variable or variables will need to be measured on a certain level again, like an ordinal level. The population is normally distributed, not skewed. More information about these assumptions can be obtained from SPSS guides. If your data do not meet the assumptions for a specific test, you may be able to use a non-parametric test instead. And for this, I would refer you to the inferential statistical decision tree flowchart provided in my previous video. Examples of tests. So you have Ttest, which is a very popular statistical analysis. It allows the comparison of the mean of two groups. Okay, so it allows you to compare the mean of two groups. Compares actual difference between two means in relation to the variation in the data, expressed as the standard deviation of the difference between the means. For example, a teacher uses two different methods to a group of EL students to see if second language acquisition proficiency levels differ and if the differences between students are in fact significant. So in this case, you will develop a null hypothesis and an alternative hypothesis. The null hypothesis would say something like method A and method B will have equal results, no difference. Alternative hypothesis would say that method A and B will have different results. So there is a difference. All right. Another example of parametric tests would be analysis of variance, which is Anova. And this test allows the comparison of three or more groups. It looks at the variation within groups, then determines how the variation would translate into variation between groups, considering the number of participants. So if observed differences are larger than what would be expected by chance, the findings are statistically significant. An example from TESOL and applied linguistics would be are TPR, ALM, and phonics method equally effective in teaching ESL pronunciation? So this is an example of a question that will be answered using Anova. Correlation, of course, is another example, and it allows an examination of the relationship between variables. The question is there a relationship between these variables? Are they positively or negatively related? A correlation coefficient of 0 means that there is no relationship between the variables. A -1, it means a negative relationship between two variables, such as the value of one variable increases, the other decreases. So it's the opposite. And then there is also a possibility of having a positive relationship when you have a relationship between two variables that move in tandem, that is, in the same direction. So this is very important note. We need to keep in mind that correlation is not causation. Okay, there is a huge difference between correlation and causation. Example: what is the relationship between age and motivation in second language acquisition? And these are sub-questions. Does motivation increase when age increases? Does motivation decrease when age increases? Or is there no significant correlation between the two? Okay. But again, this is a correlation study. It's not a causation study. Okay. All right. Linear regression is another parametric test that focuses on prediction. Linear regression is a basic and commonly used type of predictive analysis. The overall idea of regression is to examine two things. One, does a set of predictor variables do a good job in predicting an outcome or a dependent variable? And number two, which variables in particular are significant predictors of the outcome variable? All right, so do variables A and B predict event C? An example from TESOL and second language acquisition would be, does the nature of L1 and L1 proficiency predict L2 proficiency? Okay, So that's an example of linear regression case where linear regression will be used to answer this question.